Technoweld is for fusion welding aluminium without the need for expensive equipment or a very high degree of welding skill. Technoweld does not need or use a flux. Technoweld does not need an inert gas envelope. Technoweld only requires a gas torch burning butane, propane, town gas, in fact any available fuel gas or heat source, and anyone who can solder can use Technoweld. It works on any grade of aluminium and aluminium alloy, including Burma-Bright, Duraluminium, cast alloys, and very low melt alloys like Mazak, pot metals and zinc alloys. With care, it is even possible to weld magnesium alloys. Technoweld fusion welds aluminium at 380 degrees centigrade. That's some 200 degrees centigrade below the melting point of most aluminium, without using fluxes or inert gases, by uniquely using aluminium oxide in the process. Technoweld uses a soldering technique that results in a true fusion welding of aluminium. It is important to clean the joint or repair area with the stainless steel brush or aluminium oxide paper or grit to remove any traces of ferrous particles from the work area, which will have been deposited by tools used, such as drills, files or snips. You don't have to worry about any oils that have permeated the metal, as they won't affect the Technoweld process. Like soldering, it must be the heat from the aluminium that melts the Technoweld rod. Heat the general area and keep the flame moving, as this makes it virtually impossible to overheat the aluminium. The right temperature is achieved by touching the Technoweld rod on the surface of the heated aluminium in the work area. But make sure that the Technoweld rod is out of the flame. As soon as the temperature of the aluminium is at 380 degrees centigrade, the rod melts. Do not apply any more direct heat to the aluminium. Move the flame back from the workpiece. What you have now is a bead of Technoweld on an oxide layer between the molten Technoweld and the aluminium. Because although the oxide would have been cleaned off when brushed with the stainless steel, as soon as the aluminium was heated, it reoxidized immediately. The aluminium oxide is very hard, so we break through the oxide layer by scratching through the molten Technoweld with a stainless steel abrader. Once the oxide layer is just slightly broken, Technoweld gets onto the aluminium, and manganese in the Technoweld rod splits the oxygen off the aluminium oxide, depositing aluminium, leaving the oxygen free. Magnesium, which is also a constituent of the Technoweld rod, grabs the free oxygen to form magnesium oxide, which being very light, floats to the surface of the weld pool, preventing any further oxidization. But this reaction generates heat, which together with the background heat of 380 degrees centigrade raises the temperature in the molten area high enough to melt the aluminium, causing a fusion of Technoweld with the parent metal. If you are joining components, you coat both surfaces with Technoweld. Jig them together, and then reheat until the Technoweld becomes molten, and then draw a fillet. Notice how the heat is applied to both pieces of aluminium well back from the joint. Generally, the joint will be stronger than the parent metal. It is nearly as hard as mild steel and can be drilled, tapped and machined like any other metal. Now we need to spend a few minutes looking a little more closely at how you heat aluminium. Aluminium is very conductive and therefore is very good at moving heat away from where you want it to be. What you have to do is heat back from the joint area and push the heat into the area you want to work.